problems which has to do with molarity. So this first one, we're asking what is the molar concentration of 6.53 grams of what is this compound? It's magnesium nitrate, and the molar mass of it is given, and we want to know what is the concentration of that much of magnesium nitrate in 450 milliliters of water. So how should we start this problem? Who knows? Yeah, that seems like a pretty good first step to me too. So we should probably convert the 6.53 grams of magnesium nitrate into moles, and then we can just do a very, very simple mole conversion for that, right? We can just say, let's see if this is going to draw some black. A good question. Let's change that to that. All right, so we're going to take 6.53 grams of magnesium nitrate, and we're going to do the simple mole conversion factor of 1 mole over 148.31 grams, and that is going to give us how many moles? What was that? Somebody? 0.044. So does everyone else agree with that, and somebody else get the same number? All right. So if that's how many moles of magnesium nitrate we're working with, and this is how much water we're working with, and we're looking for the molar concentration, what is our next step? Yeah, we probably want to convert our 450 milliliters into liters, and we can just divide by 1,000 to get there. So this is the same as 0.45 liters, right? What's our next step? Yeah, we divide moles by liters because that's the definition of molar concentration, right? Molar concentration is talking about moles over liters. So if we know the moles and we know the liters, all we have to do is just divide our moles by our liters. And we are going to get an answer there. So if somebody wants to plug that into their calculator, it's probably going to be pretty close to 0.1. 0.978. And what are the units on that? Moles per liter or molarity, right? So big M, which is the same thing as moles over liters. So any questions on that first problem? Why we were doing things, or how we did it, or anything like that? Or does everyone feel comfortable with that kind of problem? All right, so if everyone's fine with that, let's move on to the next one. So if we have a 0.4 molar hydrochloride solution, how much of it do we need in order to neutralize 500 milliliters of a 0.25 molar sodium hydroxide solution? How should we start this problem? What was that? Right, we should write a balanced equation because we want to figure out what is the problem actually asking us. So the problem is asking us to neutralize the NaOH. So if we want to neutralize the NaOH, which is a base, we need to add an acid. Our acid is HCl. So we need to figure out how much HCl do we need for every equivalent of NaOH. And you can write a balanced equation in order to figure that out. So we can say HCl plus NaOH is going to give us what? What two products we're going to have as a result of this reaction? Right, so what salts? NaCl, right? NaCl and H2O. So now we balance this thing. Do we need to do anything to it? No, it's already balanced. We have one chlorine on both sides, one sodium on both sides, 2 hydrogens on the left, 2 hydrogens on the right, and 1 oxygen on both sides. So we're actually done with our balanced equation. So now what do we do? No. For neutralization reactions, you never want to use M1, V1 equals M2, V2. Those are for dilutions, not neutralizations.
the electric field.
So who has an idea of where should we go from here?
Is the force divided by one of the.
Yeah, molar ratios will absolutely come into play.
The electric
So,
field of charge.
do we know moles of either one of these?
So this would be 1, 2.
Yeah, we can figure out the moles of NaOH. How would we do that? Yep, first we're going to want to convert this 500 milliliters into liters. And again, we just divide by 1,000. We're going to have 0.5 liters as a result. And then what do we do? What was that? Right. We multiply this by the molarity, because if you remember, saying 0.25 molar is the same thing as 0.25 moles over liters, right? These two numbers are the same thing. We're just changing it from molarity to moles over liters. So then we can just do this simple calculation, 0.5 liters times 0.25 moles over liters. Liters are going to cancel out on both sides, and we'll be left with 0.125 moles of NaOH. So far, so good? So what do we do now? Yeah, in order to neutralize this 0.25 or 0.125 moles of NaOH, how much HCl do we need?
Electric potential.
Yeah, we need the same amount of hydrochloric acid. And the reason that we need the same amount, which somebody already mentioned, is that if we look back at our balanced equation, they're in a 1-to-1 ratio. So however much NaOH we have is the same amount of HCl we have in order to need to neutralize all the NaOH. So now we know that we are going to need 0.125 moles of HCl. So how many milliliters of the 0.4 molar solution are we going to need? Yeah, basically what she was saying is that we can set the 0.4 molar, which we're going to write as moles over liters, as being equal to 0.125 moles over an unknown amount of liters, which we're going to write as X liters. So then from here we can just do simple algebra, and we will end up with our answer, right? We're going to need to move the moles over and liters over to the same side, divide by 0.4, and we'll get our answer. That's your point, yeah. So we are going to basically end up with 0.3125, and what are the units on that? Liters, right? Which should make sense because we're looking for a volume of the 0.4 molar HCl solution. So how many milliliters of the 0.4 molar HCl solution do we need? Right. We just figured out that we are going to need 0.3125 liters of it. So if we just convert that to milliliters, we multiply by 1,000, and we're going to end up with 312.5 milliliters. So any questions on this type of question? Or did anything in this not make sense?